Well, hi, my name is Daniel Ortega Romero, and I am part of the artificial intelligence team number 3 that worked with Apodaca's Fernandes. Well, today I'm going to present our analysis on productivity challenges in the metal industry, with a specific focus on Ternium's Apodaca's plant. This presentation is the result of a collaborative data-driven project that is aimed at identifying and solving production inefficiencies using artificial intelligence, sorry. The Apodaca plant in Monterrey, which only operates with scrap, has struggled to meet its expected productivity levels. So the main question is, what are the real drivers behind the production gap? So to answer this, our project was to build a machine learning model that is capable of analyzing wide range of variables affecting production. The aim was very clear, identifying the root causes of reduced productivity at Apodaca and suggest data-driven improvements. Apodaca uses an electric arc furnace, and this process includes many independent steps, like the metallic charge, oxygen injection, preheating with gas burners, and impurity removals. Efficiency in each step plays a role in the plant overall production. So, to uncover the productivity drivers, we used machine learning, especially a random forest model that is coded in Python. This method is ideal to complex industrial datasets because it considers all variables and their interactions, providing a fast and reliable prediction model. Also, we used a correlation analysis. It was performed to evaluate the relationship between variables, the causes that is the X and the productivity that is the Y. With predictive machine learning, we identified the most important variables affecting productivity to predict future performance based on operating conditions. And then we optimized the values with the use of the differential evolution method to find the optimal combination of variables that would maximize productivity. So the results. When we ran the code, an histogram appeared. The information of the histogram was all the significant factors. We selected only the most significant factors with a significance superior to 0.05. With our code, the R square is about 92%. So in 92% of all the cases, we can correctly predict the behaviors or the outcome of the process. Now I'm going to talk about the most significant factors that are affecting productivity. We start with tap to tap without delay, the total energy, power on, power off, the charge STD, and the weight of the tons of liquid metal. Well, now I'm going to talk about some issues. When we presented this information to Ternium, they told us that 2 or 3 of these factors were resultant values, something that they don't control. So for future applications, we only need to run the same code without those factors that only were making noise. With this, the other factors would elevate their levels of significance, and thanks to this, the optimization of these variables can be better. So now we're going to talk about the recommendations. The first one is to expand the database with more relevant variables and eliminate resultant variables. When we went to the plant in Puebla, Ternium told us that some variables such as density of the scrap were one of the most important and significant values, but in our database, we didn't have that variable. The second one is to use an experiment design with the optimized values that we have here to simulate the optimal combinations of the operating parameters. We, in our original plan as a team, we were excited to do this, but because of the time of the project, we didn't do it. So yeah, it's expand the database and eliminate the resultant values and add more relevant variables. And the second one, use experiment design for optimized values that we already had here that our code told us. So in conclusion, the AI model is highly effective and accurate in identifying key drivers of productivity. Throughout understanding and proper application of these models is key to maximizing the impact and achieving more efficient and competitive manufacturing processes. And the most important part of the whole project is the integration of our artificial intelligence code that facilitates the analysis of large volumes of data and identifies opportunities for operational improvement. It's very simple. If we want to introduce new variables, we only need to add some line of codes to analyze tons of new data.